In this 3 steps to sketch, we're going to graph a shifted cotangent graph, y equals 2 cotangent of 3x plus 1. So the shift that we have is actually going to be a vertical shift. We see it there with that plus 1, and so that's how we know we should use the template for shifted graphs. All right, so as a reminder, here's our template. In step 1, we find all our essential information. In step 2, we'll plot our base pattern for cotangent. And in step 3, we'll shift those points, and then we'll sketch in the cotangent graph and repeat for however many cycles we need. All right, so starting with our essential information, our base graph, we look first for the coefficient a, which is the leading coefficient, or the number you see in front of the cotangent function, so that's 2. So we'll record that. That's going to help us set our curve shaping points for the cotangent curve when we plot the base pattern in the next step. So it's kind of showing you how vertically stretched out your cotangent curve will be for this graph. B is always the coefficient of x, so we can see here it's the 3 right in front. And that tells us we're going to have 3 cycles of our cotangent graph between 0 and pi. And we also use it to find the period. The formula for that is just pi over b for cotangent. So our period, or the length of a horizontal cycle, is pi over 3. And now that we have this basic information, we can choose how to label our axes. And the horizontal label, I think, is the most important. Take your period and divide by 4. And this will ensure that when you're plotting that starting graph, that base pattern in step 2, all of your key points will align with your horizontal tick marks. And that just makes for some nice, clean graphing. All right, so pi over 3 divided by 4, that's the same thing as multiplying by 1 over 4. So label each tick mark counting by pi over 12. And for the vertical scale, 1 will usually work well. That one's not quite as important, or you don't have to be quite as intentional. Look to that value a and make sure 1 works well, and it will in this case. So let's move over to our grid, and let's take a few minutes to get our grid labeled here. So start with that horizontal axis and count by 1 pi over 12. So we have 1 pi over 12, 2 pi over 12 reduces to pi over 6, 3 pi over 12 reduces to pi over 4, and 4 pi over 12 reduces to pi over 3. This 4th tick mark, when you're using this method of labeling axes, should match your period. So do a quick double check. We're good there, and we can keep on going. So that was 4 pi over 12. We now have 5 pi over 12. 6 pi over 12 reduces to pi over 2. 7 pi over 12. 8 pi over 12 reduces to 2 pi over 3. So if you're working along with me, I'm going to hit pause, and I'll label the left side of this axis all the same values, but with negative. All right, so here is our horizontal axis fully labeled, and we'll label our vertical axis quickly, just counting, like we said, by 1s. So now we're all set up. We're almost ready for step 2, but let's first talk about our shifts, and we'll find the asymptotes equation. So moving back over to our template, we want to find, is there a horizontal shift? Remember, we have this sort of general form of a cotangent shifted equation. It's a cotangent bx minus c plus d. We don't actually have a value for c here showing. It's 0. And so we don't have any horizontal or phase shifting going on here for this particular equation. So no need to do that. We already talked about, we do have a vertical shift. It's that plus 1 tacked on at the end. And so with vertical shifts, what you see is what you do. Plus 1 means move everything up 1 unit. Okay. All right, so we'll take care of that in step 3. And now we can look to write our asymptote generating equation. This is actually a really simple way to find the asymptotes. Sometimes that's all you need to do for a particular equation. But I like going ahead and doing it here when I'm graphing so that I can check my final graph against this equation and make sure it makes sense and is accurate. So all you have to do is take your horizontal transformations, or those inputs of the cotangent function, and set them equal to the parent asymptotes of cotangent. And we know that first one, remember, happens on the y-axis at 0 and then happens once a period. So we'll set those horizontal transformations, 3x, equal to 0 plus pi k. That's how we represent those parent asymptotes, and that's where k is an integer. Once we have this little setup, just solve for x. So all we have to do here is divide by 3. So I'm going to go ahead and write the final answer in the blank here. Our asymptotes will happen at x equals 0 divided by 3, of course, is 0. And pi divided by 3, of course, is pi over 3. And then we have that k there. So substitute in a few values for k, you'll see where some of your asymptotes should be happening. If k is 0, of course, we have that one on the y-axis. Note, we didn't have that horizontal shift. There was no phase shift, c over b. And so I think that makes sense that the asymptote would not have moved. We didn't have any horizontal shift. All right, if k is 1, we should see an asymptote happening at pi over 3. K is -1, there's one at negative pi over 3. This is just a good way to anticipate where those final asymptotes should fall. All right, so now we've done all of the analysis and really most of the work. We're ready for step 2. Lightly, or with a different color, I'm going to use light blue. We're going to plot the base cotangent pattern. And remember, that is starting with an asymptote on the y-axis. You'll have your first curve shaping point, kind of your upper curve shaping point, your 0, and then your lower curve shaping point. All right, so lightly, because we are going to shift this in the next step, we're going to put our asymptote. Your first curve shaping point happens at your first labeled horizontal tick mark, and all you have to do to get the y-coordinate is look at your value for a, so 2. All right, so lightly marking that. At the next horizontal tick mark moving right, that'll be your 0 or your x-intercept, so that's at pi over 6. And then your lower curve shaping point will happen at that third horizontal tick mark to the right. The y-coordinate's just going to be the opposite value for a, so -2 in this case. All right, so you can kind of see that cotangent curve that you could sketch in there. That's just one little cycle, and that's all there is to step 2. Now in step 3, we take care of the shifts, and this one's a relatively easy shift. We just need to move each of these points up 1. So let's go ahead and do it. Of course, moving a vertical line up doesn't change it, so here's our final asymptote. And it's just like we predicted with our asymptotes equation. It didn't move, it's on the y-axis at x equals 0. So now just take each of your lightly marked, or my light blue points, and move them up 1. And these will be your final points. So we'll make these nice and dark, and I'm marking these in green. So each of them is moved up 1. You can sketch in your cotangent curve. And here's one cycle of your graph. Now repeat for as many cycles as you want. So we'll move to the right first. We'll start with our asymptote, and here it is at pi over 3, just like we predicted with that asymptotes equation. That's when k is 1. All right, so we have the upper curve shaping point, what was the original x-intercept, or 0, and the lower curve shaping point. So we have a whole nother cycle here of cotangent. And you can work that to the left as well. So we'll work the pattern backward here. You can see we're literally just copying this pattern over and over again. That's what it means to be trigonometric. It's repetitive or cyclic. All right, so sketch that in. Notice the asymptote at negative pi over 3. Okay, and we'll do one more cycle here. Oops. Make sure we get it in the right spot. There's an asymptote here at negative 2 pi over 3. And we have 4 nice cycles of our cotangent graph. So hopefully this method really helps you when you're graphing these shifted cotangent graphs. Keep practicing. It will become second nature in no time at all. There are plenty of links in the video description for more graphing cotangent and graphing all the other trig functions, so be sure to check that out. And don't forget to subscribe so that you bookmark all these methods for when you need them later. Thanks for watching.